Hey, what's up, Mr. Suda here. Today we're going to be talking about physical versus chemical changes. Right, so changes can be classified into two different types. They can either be physical changes or they can be chemical changes. So here we have some ice on the side, some clouds over here. Formation of clouds or ice, those are physical changes of water. And then we have things like chemical changes like fire. Those are burning, those are chemical changes. Right, so let's go start off with physical changes here. So physical properties can be observed by using our senses, our sight, taste, or smell. Examples of some of them. And they can also be measured in various ways. So we can not only sense them, but they can also be measured. So we can get their length or their volume, or we can measure them using like when we do cooking, or we can get their mass. Right, so different physical properties include color, shape, volume, mass, density, state, and temperature. All of these are examples of physical properties, right? They also include viscosity, which is resistance to flowing. The higher something's viscosity it is, the more it doesn't want to flow, and the lower an object's viscosity is, or a liquid's viscosity it is, the easier it's going to flow. So, for example, peanut butter has a really, really high viscosity. Peanut butter doesn't want to flow. If you left your peanut butter out, it would move very, very, very slowly, like off of your spoon. To contrast, water has a really low viscosity. It flows really easy when you pour it out of a jar or a glass. Conductivity is also a physical property. Conductivity is whether an object is going to conduct, which means like kind of like pass through. So whether it's going to conduct electricity or heat, right? So if something conducts electricity, it means electricity can pass through it. If something conducts heat, it means heat can pass through it. We have malleability, which is the ability to change the shape of something. So for example, clay is something that is very malleable. You can change its shape very easily. Right? We have melting point. That's the point at which like a metal or a liquid is going to melt. So for example, our melting point for water is 32 degrees. Above 32 degrees Fahrenheit, our ice is going to start melting into water. Boiling point is also a physical property. That's the temperature at which a liquid or a substance is going to start boiling. So for example, for water at 212 degrees Fahrenheit, our water is going to start boiling and turning into a gas. These are all physical properties. Right, so knowing physical properties is useful because it can help us to do things like identify minerals, choosing a material to use when we're building something. So a physical property that's going to be useful to make instruments out of, like we wouldn't really want to make an object or an instrument out of, for example, like paper. You can't really make a trumpet out of paper. It wouldn't hold up well. It wouldn't be strong enough. We want to use something that's going to allow sound to pass through it easier and cause reverberations that are going to make our instrument sound better and more powerful. So we're going to use something like a metal instead of like paper or a styrofoam or a plastic, right? And if we know physical properties, we can also separate substances in a mixture. For example, if we have sand and water, if we know about our physical properties, we can separate those two things out of a mixture. Right? A physical change occurs when the appearance of a substance changes. So this is like our definition here. So a physical change occurs when just the appearance of something changes. Right? But chemically, the substance is still going to be the same. So if I go back here, here's water in a liquid form. Now here's water in an iceberg. It's in a solid form. It's ice. They're still the same substance, so it's only a physical change that's occurred. The individual molecules do not change. A physical change is only a change in appearance. All right, so during some physical changes, matter simply changes from one state to another. So for example here's my water cycle. My water as a liquid, it evaporates, turns into a cloud as water in a gas form, and then our water droplets condense and they fall back down to the ground as rain. Through this entire time, no chemical changes have occurred. These are all physical changes of water changing from one physical state to another. right? So evaporating, melting, freezing, and condensing are all examples of physical changes. So uh, these types of changes. So for example, these state changes, water can go through all of these. So water can evaporate into a gas, it can melt into a liquid, it can freeze into a solid, it can condense back into a liquid. At no point did the chemical formula of the water change, only its physical appearance did. Right, so during some physical changes, an object's size or shape may be altered. So we have these balloon people down there. All of them are made of balloons. The balloons themselves aren't changing, but if the shape changes or the size changes, those are to be considered physical changes. But because only the size or the shape change, only a physical appearance changed, then a chemical change did not occur. This has to be a physical change when you're making these balloon people here. All right, two other examples here. So folding or tearing paper are also examples of physical changes. We're not changing the chemical formula of the paper. We're just changing its shape. Or turning wood into sawdust here. Again, we're not changing the chemical formula of the wood. We're just taking the wood and making it into smaller pieces. It's a physical change. All right, a physical change also occurs when substances are mixed into something and it dissolves. So, for example, here, if I dissolve like my sugar powder from like a Kool-Aid or something and I put it into the water, that's an example of a physical change because I can evaporate that water, I can make that water dry up, and my sugar will still be left behind. Kind of like if you go to the beach and you go into the ocean, you come back out and you dry off in the sun, you'll have salt crystals on your body because the water evaporated away. So dissolving something or mixing something up is an example of a physical change. Right, so in a physical change, substances like water keep their original properties, right? So water is still going to be water, no matter if it's frozen, if it's in a gas, or if it's liquid. All right, now let's get started with chemical changes. So chemical properties include flammability, so whether something is going to light on fire, or reactivity, whether something is going to react to another chemical. So for example, here we have rust, and when metal is exposed to oxygen, it will rust, right? So whether it's going to do that or not is an example of reactivity, whether it's going to react with another chemical substance. Recognizing chemical changes is important. Two types of giveaways that we can use to tell whether a chemical change has occurred is the production of a gas or the formation of a precipitate. And we'll look at some of those examples, right? So a chemical change occurs when chemical reactions take place. So, for example, here I have this yellow liquid. I have this clear liquid, but when I combine them, I get this red liquid. This red liquid here. And because I have a color change is usually an indicator that a chemical reaction has taken place. So not only the matter's physical properties change when a chemical reaction occurs, but it actually changes into something new. So for example here, we have a copper wire getting put into a little beaker of silver nitrate. And when the copper dissolves into that silver nitrate, it creates copper nitrate, and there's silver left over also in solution there, but it changes the color of the silver nitrate into this nice blue color from the copper. Right, so energy is also involved in all chemical reactions. In order for a chemical reaction to occur, there has to be some sort of exchange of energy. So I have my match here, it lights on fire, and I'm having energy produced, and I'm changing the chemical formula of, for example, the tip of the match there. All right, the substances produced during a chemical reaction are different from the original substances with new properties. So I have my marshmallow here. I light my marshmallow on fire. I want to cook it up. It's now changed the chemical arrangement of my marshmallow here, at least on the outside that's been cooked so far already. Same thing with these ones up here that we've already talked about. All right, so signs that a chemical reaction took place. A solid precipitate is formed at the bottom of the test tube. So a precipitate is just like a solid substance that forms in a solution or a liquid. So, for example, when I'm dropping in, so let's say I pour two liquids together and I get like these little tiny crystals that are inside my liquid here. These are precipitates. You also might get precipitates when, for example, when a solution is supersaturated and there's extra crystals left behind. Those are also an example of a precipitate. Right? Heat, smoke, sound, odor, or light are also all examples, or not examples, they're hints or indications that a chemical reaction might have occurred. So you may smell the skunk, or you see the match has been burning, or you might get an explosion, or you might have something that glows, a change in light. All these are indications that a chemical reaction might have occurred. Another example of something that could tell us whether it's a chemical reaction is whether a gas is produced, whether it causes bubbling, fizzing, or foaming. So if something bubbles or it fizzes, that might be an indication that, hey, a chemical reaction might have happened. A change in color occurs is also a good indicator whether a chemical reaction might have happened. But keep in mind, these are only clues. The only way to know for sure if a chemical change has occurred is if the matter has changed into a new substance. It's got to go from one thing to a whole new thing in order for a chemical change to have to have occurred. All right, so some common examples of chemical changes include rusting is a chemical change where for example, we're turning iron into iron oxide, and that's iron oxide, that's what rust is, and we're changing the chemical formula of that metal. Tarnishing. So for example here, our Statue of Liberty used to be a nice copper color, and it is tarnished over time after being exposed to oxygen, and now it's got that green tarnish on it. Same thing that happens to your pennies here. Burning is also an example of a chemical change. You're taking the wood and you're lighting it on fire, and you're changing it into a different substance. Digesting is also an example of a chemical reaction. Your stomach acids are going to dissolve the food and then change it into a new substance that your body can use as fuel. Right? So let's wrap up here. So is it a chemical change or a physical change? Right? So for it to be a physical change, the composition of the matter stays the same. The things that make up the matter are the same. And for a chemical change to have occurred, the matter has to change into a new substance. So a physical change is only a change in appearance, while a chemical change is a change in the original matter to turn into a whole new substance. So this is just a change in appearance, a physical change, and then a chemical change is changing into a whole new substance. Right, so that wraps it up for physical and chemical changes. Thanks for watching. I hope you learned something useful, and I'll see you in the next video.